Question 1a. By using mathematical tables, evaluate those values to 3 significant figures. Okay, so this is the logarithm problem. We are going to use a logarithm table to evaluate the expression. To simplify the process, we are going to summarize the result into a table. Okay, so let x equals to cube root 0.072 times 81.3 squared over under root 23,140. Okay, so next let us apply the log both sides. Our equation is going to be log x equals to log in bracket cube root 0.0072 times 81.3 squared over under root 23,140. Okay, so now let us prepare the table which will summarize the results of our logarithms. Okay, so our table will have a column for number, and then we'll have a column for the standard form, and then we are going to have the column for the logarithm. Okay, so first let us start with this first number, cube root 0.0072. Okay, so next let us write this number in a standard form. So writing this in a standard form, we are going to have in brackets 7.2 times 10 power negative 3 power 1 over 3. Okay, so for this one, to find its logarithm, we are going to read 7.2 from the table, and we are going to add by 3 from 10 power negative 3. Then the value is going to be by 3.8573. And then we are going to apply the exponential rule of logarithm, and we are going to multiply by 1 over 3. So the equation is going to be 1 over 3 times by 3.8573, of which, solving the values here, we are going to have by 1.2858. Okay, so our second number is 81.3 squared. Okay, so let us write this in a standard form. We are going to have 8.13 times 10 power 1 squared. Okay, so reading 8.13 from the table and adding 1 from 10 power 1, we are going to have 1.9101. So the logarithm for this one is going to be 2 times 1.9109, of which, solving this, we are going to have 3.8202. Okay, so now to find the value of a numerator, we are going to add these two values by applying the additional rule of logarithm. So adding these values, we are going to have 3.1060, and this is going to be the value of our numerator. Okay, so our next number is under root 23,140. So writing this in a standard form, we are going to have 2.314 times 10 power 4 power a half. Okay, so for this one, reading 2.314 from the table and 4 from 10 power 4, we are going to have 4.3644. Then here the value for the logarithm is going to be 1 over 2 times 4.3644, of which solving this we are going to have 2.1822, and this is the value of our denominator. Okay, so next we are going to apply the quotient rule of logarithm by taking the numerator minus denominator. So finding the values, we are going to have 0.9238. Then log x equals to 0.9238. Okay, so let us now apply antilog. We are going to have x equals to antilog 0.9238. Okay, so now reading the values of this one from the antilog table, we are going to have x equals to 8.3907, and this is going to be our answer. Part B of the question, rationalize that expression. Okay, so this is the radical problem. To rationalize the expression, we multiply both the numerator and the denominator by the value of the denominator with the opposite sign. So the value of the denominator which we are going to use is going to be 1 plus under root 3. Okay, so let us use this value into our equation. We are going to have in brackets 2 plus under root 3 times 1 plus under root 3 over in brackets 1 minus under root 3 times 1 plus under root 3. Okay, so next we are going to expand our expression. For the numerator, we are just going to multiply the expression, and for the denominator, we are going to use the difference of two square concept. So our equation is going to be 2 times 1 plus 2 times under root 3 plus under root 3 times 1 plus under root 3 times under root 3 over 1 squared minus under root 3 squared. Okay, so solving this, we are going to have 2 plus 2 times under root 3 plus under root 3 plus 3 over 1 minus 3. Okay, so now let us combine the like terms. We are going to have 5 plus 3 times under root 3 over negative 2. Simplifying this, we are going to have negative 5 over 2 minus 3 times under root 3 over 2. And this is going to be our answer. Question number 2, part A. Find the value of x for which 2 power x dot 16 equals to 1 over 8 power x. Okay, so this is the exponential problem. We have to remember that the dot between 2 and 16, it means multiplication. Okay, so first let us express each term in the power to base 2. So our equation is going to be 2 power x dot 2 power 4 equals to 2 power negative 3x. Okay, so next we are going to add the exponents for our left hand side because their bases are the same. So our equation is going to be 2 power x plus 4 equals to 2 power negative 3x. Next, we are going to equate the exponents from both sides because their bases are the same. So our equation is going to be x plus 4 equals to negative 3x. Okay, so now let us combine the like terms. Our equation is going to be x plus 3x equals to negative 4. Simplifying more, we are going to have 4x equals to negative 4. Okay, so now let us divide by 4 both sides. We are going to have x equals to negative 1. And this is the value of x required. Part B of the question, we are supposed to solve those logarithms which we've been given from the question. Okay, so this is the logarithm problem. So from the expression given, first we are going to apply the quotient rule in order to combine the like terms for our left hand side, and then we are going to apply exponential rule for our right hand side. So our expression is going to be log base a in brackets x squared plus 3 over x equals to log base a 2 squared. Okay, so now we can see that the bases are the same. Then we are going to equate their values. So our equation is going to be x squared plus 3 over x equals to 4. Okay, so now let us multiply both sides by x. We are going to have x squared plus 3 equals to 4x. Okay, so let us now write this equation in a quadratic format. Our equation is going to be x squared minus 4x plus 3 equals to 0. Okay, so we are going to solve this quadratic equation by the general formula for quadratic, which says x equals to negative b plus or minus under root b squared minus 4ac over 2a. Okay, so from our equation, a is 1, b is negative 4, and c is 3. So let us substitute these values into our formula. We are going to have x equals to negative 4 in brackets negative 4 plus or minus under root negative 4 squared minus 4 times 1 times 3 over 2 times 1. Solving this, we are going to have x equals to 4 plus or minus 2 over 2. So x will be equal to 4 plus 2 over 2, or x will equal 4 minus 2 over 2, of which after solving the values we are going to have x equals to 3 or x equals to 2. And these are the values of x required. Question number 3, part A. Mr. Bean lived a quarter of his life as a child, a fifth as a teenager, and a third as an adult. He then spent 13 years in old age. How old was he when he died? Okay, so let x be the age of Mr. Bean when he died. So we are going to have quarter of his life will equal 1 over 4x. A fifth of his life will equal 1 over 5x. A third of his life will equal 1 over 3x. Okay, so next we are going to take the sum of all the terms. So the sum is going to be 1 over 4x plus 1 over 5x plus 1 over 3x, of which after summing the values we are going to have 47 over 60x. Okay, so now let us find the number of years he spent in his old age. So remaining years will be x minus 47 over 60x, which after solving the values we are going to have 13 over 60x. But we have been given in the question that he spent 13 years in his old age. So we are going to equate this equation to 13. Our equation is going to be 13 over 60x equals to 13. Okay, so now let us solve for x. We are going to have x equals to 13 times 60 over 13, of which after solving the values we are going to have x equals to 60. Therefore, he died when he was 60 years old. Part B of the question, A and B are subset of the universal set U. Find number of A intersection B given that number of A equals to 39, number of A complement intersection B complement equals to 4, number of B complement equals to 24, and number of universal set equals to 65. Okay, so this is the set problem. We know that number of A union B equals to number of A plus number of B minus number of A intersection B. Okay, so let us call this as our equation number 1. Okay, so from this one, number of B, which equals to number of U minus number of B complement, let us substitute number of B complement with 24 and the number of universal set with 65. Our equation is going to be number of B equals to 65 minus 24, of which solving this we are going to have number of B equals to 41. Also, number of A union B equals to number of universal set minus number of A union B complement. Okay, so we have been given number of A complement intersection B complement equals to 4, but number of A complement intersection B complement equals to number of A union B complement. Therefore, substituting number of A union B complement, which equals to 4, and number of universal set, which equals to 65, our equation is going to be number of A union B equals to 65 minus 4, of which solving this we are going to have number of A union B equals to 61. Okay, so now from our equation number 1 here, let us now substitute values of number of A, which equals to 39, number of B, which equals to 41, and the number of A union B, which equals to 61. We are going to have 61 equals to 39 plus 41 minus number of A intersection B. Okay, so now let us make number of A intersection B as a subject. Our equation is going to be number of A intersection B equals to 80 minus 61, of which solving this we are going to get 19, and this is the value of number of A intersection B. Question number 4, given that A equals to 3,4, B equals to 1,4, and C equals to 5,2. For part A of the question, we are supposed to determine D equals to A plus 4B minus 2C. Okay, so this is the vector problem. First step, let us express the points in terms of component I and j. So our expressions will be A equals to 3i plus 4j. B equals to I plus 4j. And C equals to 5i plus 2j. Okay, so now for D equals to A plus 4B minus 2C, let us substitute the values of A, B, and C. So our equation is going to be D equals to, in brackets, 3i plus 4j plus 4 times, in brackets, I plus 4j minus 2 times, in brackets, 5i plus 2j. Okay, so now let us open the brackets. Our equation is going to be D equals to 3i plus 4j plus 4i plus 16j minus 10i minus 4j. Okay, so now let us combine the like terms. Our expression is going to be D equals to negative 3i plus 16j. And this is the value of D required. Part B of the question, we are supposed to determine the magnitude of vector D, leaving our answer in a form of m times under root n. Okay, so magnitude of the vector D is given by D equals to under root x squared plus y squared. Okay, so let us substitute the values of x, which equals to negative 3, and y, which equals to 16. Then our equation is going to be D equals to under root negative 3 squared plus 16 squared, of which, solving this, we are going to have D equals to under root 265. And this is the magnitude required. For part C, we are supposed to determine the direction cosines of D, and hence we are supposed to show that the sum of the squares of these directional cosines is 1. Okay, so for this one, directional cosines are given by the following formula, which says cos alpha equals to x component over magnitude of a vector, and cos beta equals to y component over magnitude of a vector. Okay, so let us now substitute the values for x and y. We are going to have cos alpha equals to negative 3 over under root 265, and cos beta equals to 16 over under root 265. And these are the direction cosines. Okay, so now let us show that the sum of the squares of these directional cosines is 1. We are going to take cos square alpha plus cos square beta, of which, substituting the values which we have, we are going to have negative 3 over under root 264 squared plus 16 over under root 265 squared, of which, solving the values, we are going to have 1. Therefore, this shows that the sum of the squares of the directional cosines is 1. Question number 5, part A. If a polygons X and Y are similar and their area are 16 cm squared and 49 cm squared respectively, what is the length of a side of a polygon Y if the corresponding side of a polygon X is 28 centimeters? Okay, so this is the similarity problem, and we know that the square of ratio of corresponding sides for similar figures gives the ratio of their areas. Okay, so now let B be the length of a side for polygon Y. So we are going to have 28 over L squared equals to 16 over 49. Okay, so let us apply cross multiplication for this function. We are going to have L squared times 16 equals to 49 times 28 squared. Okay, so now let us divide by 16 both sides. Our equation is going to be L squared equals to 49 times 28 squared over 16. Solving this, we are going to have L squared equals to 2401. Okay, so now let us apply the square root both sides. We are going to have L equals to 49. So the length of a side of a polygon Y is 49 centimeters. Part B of the question, Roman 1, show whether triangles PQR and ABC are similar or not. Okay, so from the figure we've been given, angle PQR equals to angle ACB, which equals to 109. And also angle RPQ equals to angle BAC, which equals to 49. And angles PQR and angle ABC are third angles for the triangle. Then they must also be equal. Therefore, this shows that the triangles are similar by AAA theorem. Roman 2, we are supposed to find the relationship between Y and X in the triangles given above. Okay, so since the triangles are similar, then their corresponding sides must have a constant ratio. That is PQ over AC equals to RQ over BC also equals to PR over AB. Okay, so now let us substitute the values which we've been given. We are going to have 10 over 16 equals to Y over X equals to 25 over 15. Okay, so now let us consider this second part, which says Y over X equals to 25 over 15. Let us now simplify our right hand side. We are going to have Y over X equals to 5 over 3. Okay, let us make Y as a subject. Our equation is going to be Y equals to 5 over 3x. And this is the relationship required. Question number 6, part A. The power P used in an electricity circuit is directly proportional to the square of the current I. When the current is 8 ampere A, the power used is 640 watts W. Okay, so for Roman 1, we are supposed to write down the equation relating the power and the current. Okay, so this is the variation problem. We've been told that power is directly proportional to the square of the current. Okay, so now let us introduce the constant of proportionality K. Our equation is going to be P equals to K I squared. And this is the relationship between power and the current requested. For Roman 2, we are supposed to calculate the current I when the circuit uses 360 watts. Okay, so from the relationship obtained above, which says P equals to K I squared, let us make K as a subject. Our equation is going to be K equals to P over I squared. Okay, so now let us substitute P with 640 watts and the current as 8 ampere. Our equation is going to be K equals to 640 over 8 squared, of which, solving this, we are going to have K equals to 10. Okay, so now from the formula, let us substitute calculated values of K and the power as 360 watts. We are going to have 10 equals to 360 over I squared. Okay, now let us make current as a subject. Our equation is going to be I equals to under root 36. Then solving this, we are going to have I equals to 6. So when circuit uses 360 watts, current is going to be 6 amperes. And this is the answer required. Part B of the question, if x star y is defined as 1 over 2 times in brackets x plus y, find 5 star negative 2 star 3 star negative 4. Okay, so we have been given x star y equals to 1 over 2x plus 1 over 2y. Okay, so now let us take 5 star negative 2 from 5 star negative 2 star in brackets 3 star negative 4, and then we are going to substitute 5 and negative 2 as values of x and y respectively into the given equation. Our equation is going to be 5 star negative 2 equals to 1 over 2 times 5 plus 1 over 2 times negative 2. Okay, so solving this, we are going to have 5 star negative 2 equals to 3 over 2. Also, let us take 3 star negative 4 from 5 star negative 2 star 3 star negative 4, then substitute 3 and negative 4 as values of x and y respectively into the given equation. Our equation is going to be 3 star negative 4 equals to 1 over 2 times 3 plus 1 over 2 times negative 4. Calculating this, we are going to have 3 star negative 4 equals to negative 1 over 2. Okay, so finally, let us substitute 3 over 2 star negative 1 over 2 in a given equation. Then we are going to have 3 over 2 star negative 1 over 2 equals to 1 over 2 times 3 over 2 plus 1 over 2 times negative 1 over 2, of which, solving this, we are going to have 3 over 4 minus 1 over 4. Solving further, we are going to have 1 over 2. Therefore, this is the value required. Question number 7a. By selling an article at shillings 22,500, a shopkeeper makes a loss of 10%. At what price must the shopkeeper sell the article in order to get a profit of 10%? Okay, so this is the percentage problem. We are going to let Y be the buying price, and let us recall the formula for the percentage loss, which says selling price minus buying price over buying price times 100. Okay, so now let us substitute the given values which we have. We have to remember that the loss is represented by a negative sign. So our equation is going to be negative 0.1 equals to 22,500 minus Y over Y. Next, let us multiply by Y both sides. Our equation is going to be negative 0.1 Y equals to 22,500 minus Y. Okay, so next, solving for Y and making Y as a subject, we are going to get Y equals to 25,000. Okay, so now from the formula above, let us replace the percentage loss with the percentage profit of 10%, and then we are going to substitute calculated buying price in order to get the selling price. So our equation is going to be 0.1 equals to selling price minus 25,000 over 25,000. Let us now multiply by 25,000 on both sides. Our equation is going to be 0.1 times 25,000 equals to selling price minus 25,000. Okay, so solving for the selling price, our final value is going to be 27,500. And this is going to be our answer. Part B of the question, an alloy consists of 3 metals A, B, and C in the proportion of A ratio B equals to 3 ratio 5 and B ratio C equals to 7 ratio 6. We are supposed to calculate the proportion A ratio C. Okay, so this is the ratio problem. So first, let us take this A ratio B, which equals to 3 ratio 5. Let us now write this one in the fraction form. We are going to have A over B equals to 3 over 5. Okay, so next, let us make A as a subject. Our equation is going to be A equals to 3 over 5B. So we are going to call this as equation number 1. Okay, so for the next ratios, for this one, B ratio C equals to 7 ratio 6. Let us write this in a fraction form. We are going to have B over C equals to 7 over 6. Okay, so let us make C as a subject. Our equation is going to be C equals to 6 over 7B. So we are going to call this as equation number 2. Okay, so next, let us divide equation 1 by equation 2. We are going to have A over C equals to 3 over 5b divided by 6 over 7b. Simplifying this, we are going to have a over c equals to 7 over 10. Then next, we are going to write this fraction into a ratio. Then we are going to have a ratio c equals to 7 ratio 10. And this is going to be our answer. Question number 8, part A. If the fifth term of an arithmetic progression is 23 and the 12th term is 37, find the first term and the common difference. Okay, so this is the arithmetic progression problem. Okay, so first let us recall the formula to find any term in arithmetic progression, which says an equals to a1 plus, in brackets, n minus 1 times d. Okay, so for the fifth term, let us substitute an with 23 and n with 5. Our equation is going to be a1 plus, in brackets, 5 minus 1 times d equals to 23. Of which, simplifying this, we are going to have a1 plus 4d equals to 23. And we are going to call this as equation number 1. Okay, so for the 12th term, let us substitute an with 37 and n with 12. We are going to have a1 plus, in brackets, 12 minus 1 times d equals to 37. Okay, so now let us simplify this. We are going to have a1 plus 11d equals to 37. Okay, so we are going to call this as equation number 2. Okay, so now we have two simultaneous equations. So next, let us take equation number 1. We are going to minus with the equation number 2. So our equation is going to be 11d minus 4d equals to 37 minus 23. Of which, solving this, we are going to have 7d equals to 14. Okay, so now let us divide by 7 both sides. Our equation is going to be d equals to 2. Okay, so now we have the value for d. Let us now substitute d, which equals to 2, into equation number 1 in order to solve for a1. Our equation is going to be a1 plus 4 times 2 equals to 23, of which it becomes a1 plus 8 equals to 23. Let us now make a1 as a subject. We are going to have a1 equals to 15. Therefore, the first term is 15 and our common difference is 2. Part B of the question, find the sum of the first 4 terms of a geometric progression which has a first term of 1 and a common ratio of 1 over 4. Okay, so first let us recall the formula to find the sum of the geometric progression, which says sum equals to g1 times, in brackets, r power n minus 1 over r minus 1, of which g1 equals to the first term, r equals to the common ratio, and n is a number of terms. Okay, so from our question, g1 is 1, the common ratio is 1 over 4, and the number of terms is 4. Okay, so now let us substitute these values into our formula. Our equation is going to be sum equals to 1 times, in brackets, 1 over 4 power 4 minus 1 over 1 over 4 minus 1, of which after solving the values we are going to have sum equals to 255 over 192, and this is going to be our answer. Question number 9, part A. Find the length AC from the figure below. Okay, so we've been given the sketch there. In order to solve the problem, let us use the following sign formula, which says A over sine A equals to B over sine B. Okay, so looking at our sketch, A is 22.2 centimeters. Angle A is 26 degrees and angle B is 86 degrees. Okay, so let us substitute these values into our formula. We are going to have 22.2 over sine 26 equals to B over sine 86. Okay, so now let us make B as a subject. We are going to have B equals to 22.2 times sine 86 over sine 26. Okay, so reading the values of these signs from the table, our equation is going to be B equals to 22.2 times 0.99761 over 0.4384. Okay, so solving this, we are going to have B equals to 46.95. Therefore, the length AC equals to 46.95 centimeters. Part B of the question, a ladder reaches the top of a wall 18 meters high when the other end of the ground is 8 meters from the wall. Find the length of the ladder. Okay, so to solve this question, let us first sketch the problem. So we are going to draw the line which will represent a wall, which will equal 18 meters. And then we are going to draw another line for the ground, which will equal 8 meters. And then we are going to draw another line for the ladder. Now we can see that we have already sketched a triangle. And here for the length of a ladder, we are going to put x. Okay, so now in order to find the value of x, we are going to use a Pythagoras theorem, which says c squared equals to a squared plus b squared. Okay, so from our sketch, c equals to x, a equals to 18, and b equals to 8. Okay, so now let us substitute these values into our formula. We are going to have x squared equals to 18 squared plus 8 squared, of which, computing the values and applying square root both sides, our equation is going to be x equals to under root 388. Okay, so reading the square root from the table, our equation is going to be x equals to 19.70. Therefore, the length will be 19.7 meters. Question number 10, part A. Solve for x if 6 over x minus 4 equals to 1 plus 4 over x. Okay, so this is the algebra problem. Okay, so first let us combine the terms from our right hand side. Our equation is going to be 6 over x minus 4 equals to x plus 4 over x. Okay, so next let us cross multiply this equation. We are going to have in brackets x minus 4 times in brackets x plus 4 equals to 6x. Okay, so next let us expand the left hand side. We are going to have x squared minus 16 equals to 6x. Okay, so next let us rearrange this equation in a quadratic format. Our equation is going to be x squared minus 6x minus 16 equals to 0. So now we are going to solve this quadratic equation by general formula of a quadratic equation, which says x equals to negative b plus or minus under root b squared minus 4ac over 2a. From the equation we have a equals to 1, b equals to negative 6, and c is negative 16. Okay, so now let us substitute these values into our formula. Our equation is going to be x equals to 6 plus or minus under root 6 squared minus 4 times 1 times negative 16 over 2 times 1, of which after solving the values we are going to have x equals to 6 plus or minus 10 over 2. Okay, so the values of x will be x equals to 6 plus 10 over 2, or x equals to 6 minus 10 over 2. After solving the values, we are going to have x equals to 8, or x equals to negative 2. And these are the values of x required. Part B of the question, if the sum of two numbers is 3 and the sum of their squares is 29, find the numbers. Okay, so first let x equals to first number, and then let y equals to second number. Then we are going to have x plus y equals to 3, and we are going to call this as equation number 1. And then we are going to have also x squared plus y squared equals to 29. And we are going to call this as equation number 2. Okay, so next, let us make y as a subject from the equation number 1. We are going to have y equals to 3 minus x. And we are going to call this as equation number 3. Okay, so now let us substitute equation number 3 into equation number 1. Our equation is going to be x squared plus, in brackets, 3 minus x squared equals to 29. Let us now expand the squares. We are going to have x squared plus 9 minus 6x plus x squared equals to 29. Okay, next let us combine the like terms and rearrange the equation in a quadratic format. We are going to have 2x squared minus 6x minus 20 equals to 0. To simplify this further, we are going to divide by 2 for each term. Then our expression is going to be x squared minus 3x minus 10 equals to 0. Now let us solve the quadratic equation by general formula, which says x equals to negative b plus or minus under root b squared minus 4ac over 2a. From our equation, x equals to 1, b equals to negative 3, and c is negative 10. So now let us substitute these values into our formula. Our equation is going to be x equals to 3 plus or minus under root negative 3 squared minus 4 times 1 times negative 10 over 2 times 1. After solving the values, we are going to have x equals to 3 plus or minus 7 over 2. So here we have x equals to 3 plus 7 over 2, or x equals to 3 minus 7 over 2, of which after solving the values we are going to have x equals to 5 or x equals to negative 2. So there we have the values for the first term. Okay, so now to find the second term, let us take equation number 3 and substitute the values of x inside. We are going to have y equals to 3 minus 5 or y equals to 3 minus negative 2, of which after solving the values we are going to have y equals to negative 2 or y equals to 5. And those are the values for the second term. Question number 11. Anna and Mary are tailors. They make X blouses and Y skirts each week. Anna does all cutting and Mary does all the sewing. To make a blouse, it takes 5 hours of cutting and 4 hours of sewing. To make a skirt, it takes 6 hours of cutting and 10 hours of sewing. Neither tailor works for more than 60 hours a week. Part A of the question, for sewing, show that 2x plus 5y is less or equal to 30. Okay, so this is the linear programming problem. Since we have been told that it takes 4 hours for sewing a blouse and 10 hours for sewing a skirt, and the total time spent by Mary is not more than 60 hours in a week, then our inequality is going to be 4x plus 10y is less or equal to 60. Okay, so for this one, let us divide by 2 for each term in order to simplify this. So our inequality is going to be 2x plus 5y is less or equal to 30. And this has been shown as requested from our question. Part B of the question, we are supposed to write down another inequality in X and Y for the cutting. Okay, so we have been told that it takes 5 hours to cut a blouse and 6 hours to cut a skirt, and the total hours spent is not more than 60 hours. Then our inequality is going to be 5x plus 6y is less or equal to 60. And this is another inequality shown. Part C of the question, if they make at least 8 blouses each week, write down another inequality. Okay, so for making at least 8 blouses, the inequality is going to be x is greater or equal to 8. And this is going to be our answer. And for part D, using 1 centimeter to represent 1 unit of each axis, show the information in part A, B, and C graphically, and then shade only the required region. Okay, so for the inequalities obtained, we can get the boundary lines. So our boundary lines are going to be 2x plus 5y equals to 30, 5x plus 6y equals to 60, and our last boundary line is going to be x equals to 8. Okay, so now to draw the graph, let us find the sample points from the lines which we have been given. So we are starting with this one, 2x plus 5y equals to 30. So when x equals to 0, y is going to be 6, and the point is going to be 0, 6. And when y equals to 0, x is going to be 15, and our point is 15, 0. And for this second line, which says 5x plus 6y equals to 60, when x equals to 0, y is going to be 10, and the point is 0, 10. And then when y equals to 0, x is going to be 12, and our point is 12, 0. Okay, so next we are going to start by drawing x and y axis, and next we are going to draw 2x plus 5y equals to 30. Then the next line is 5x plus 6y equals to 60. And finally, we are going to draw line x equals to 8. And also we've been told to shade the required region. Therefore, our final graph will look like this. Question number 12. In the survey of the number of children in 12 houses, the following data resulted. So we have been given several data there, and we are supposed to show this data in a frequency distribution table. Okay, so something to remember is a frequency distribution table is a table that contains the data with their corresponding frequencies. So we are going to sketch our frequency distribution table, which is going to have 2 columns, the house and their corresponding frequencies. So here we are going to have a house, and here we are going to have their frequencies, which will be represented by the number of children in each house. So we have 12 houses, so we are going to start listing them. So here is house number 1, here is house number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10, number 11, and number 12. And for the next column, we are going to fill the number of children in each house. So for the first one, we've been given from the question. So here is 1, here is 2, here is 3, here is 4, here is 2, here is 2, here is 1, here is 3, here is 4, here is 3, here is 5, and the last one is 3. And this is the table required. Part B of the question, we are supposed to draw a histogram and a frequency polygon to represent this data. Okay, so for this one, we are going to start by drawing a histogram. Then you have to remember that histogram is the bar graph drawn by frequencies against the given data for ungrouped data. Okay, so we start by drawing axis, and we are going to label number of children for y-axis and houses for x-axis. And then we are going to mark the point, and we are going to draw the bar for each information from the table. And then we are going to finally shade the bars. After doing that, our final graph will be like this. Okay, so next we are supposed to draw a frequency polygon. Okay, the frequency polygon is the line graph drawn by frequency against the data given the ungrouped data. Okay, so from the graph above, in steady bars, we now connect the point with a straight line. And our final graph will look like this. For part C, we are supposed to calculate the mean and the mode number of children per house. Okay, so first let us find the mean. From the information given, we are saying that mean of children per house equal to total number of children divided by number of houses given. Okay, so from the data given in our question, the total number of children is 33 and the number of houses is 12. So the mean is going to be 33 divided by 12. Of which, after solving the values, we are going to have the mean equals to 2.75. But since this is the number of people, we are going to approximate it to 3. Therefore, we are going to say the mean of children per house equals to 3 children. Question number 13, part A. An open rectangular box measured externally 32 cm long, 27 cm wide, and 15 cm deep. If the box is made of wood 1 cm thick, we are supposed to find the volume of a wood used. Okay, so to find the volume of a wood used, we first find the difference in volume between the external part and the internal part of the box. Okay, so now for each dimension which we've been given from the question, we are going to minus 1 centimeter. That is the thickness of a wood used. So we start by the length which we've been given is 32 centimeters. Then minus 1, we are going to have 31 centimeters. Okay, for the width, we have been given 27 centimeters. Then minus 1, we are going to have 26 centimeters. And for the depth, the given value is 15 centimeters. So minus 1 centimeter, we are going to have 14 centimeters. Okay, so now let us recall the formula to find a volume, which says volume equals to length times width times the depth. Okay, so now to find the volume of wood used, we are going to take the volume of the external part and then we are going to minus the volume of the internal part. Okay, so using the same formula for the volume, to find the volume of external part, we are going to take 32 times 27 times 15. And also to find the volume of the internal part, we are going to take 31 times 26 times 14. Okay, so after solving the values, the volume for the external part is going to be 12,960. And the volume for the internal part is going to be 11,284. So the volume of wood used is going to be 12,960 minus 11,284, of which after calculating the values we are going to have 1,676 centimeter cubic, and this is an answer. Part B of the question, find the distance in kilometers between two towns P and Q along a line of a latitude correctly to 4 decimal places. Okay, so this is the Earth as a sphere problem. Since the points are not located in a straight line, we are going to use the following formula, which says distance equals to 2 pi r psi cos theta over 360, of which r is the radius over the Earth, which we know that it is 6,370 kilometers. Psi is the difference in longitudes, and then we've been given longitudes there. We have 39.8 degrees. Then we are going to minus 30.5 degrees, of which after solving the values we are going to have 9.3 degrees. Okay, and theta is the latitude given, which we've been given is 12.4 degrees. Okay, so now let us substitute these values into our formula. We are going to have distance equals to 2 times 3.14 times 6,370 times 9.3 degrees times cos 12.4 degrees over 360, of which after solving the values we are going to have 1,009.3189, and this is the distance needed in kilometers. Question number 14, part A. The following balances were extracted from the ledgers of Mr. and Mrs. Mkomo business on 31st January. We are supposed to prepare a trial balance. Okay, so this is an accounting problem. So we are going to draw the trial balance having account with the debit and the credit column, and then we are going to fill the values given based on their nature, whether they are on a debit or on a credit side. So the first column is account name, and then the next one is the debit, and this one is a credit. Okay, so we start with the capital, which has the credit balance of 30,000, And next is the discount allowed, which has a debit balance of 4,000. The next one is insurance account with a debit balance of 3,000. The next one is the sales account with a credit balance of 68,000. The next one is the furniture account with a debit balance of 25,000. The next one is the purchases account with a debit balance of 54,000. The next is cash balance with a debit balance of 18,000. Next is the drawing with 12,000 in a debit balance. Next is the creditors with a credit balance 76,000. Next is the motor vehicle account with a debit balance of 45,000. Next is the electricity account with debit balance of 5,000. Next one is the discount received with a credit balance of 7,000. And the last one is the debtors with a debit balance of 15,000. After summing the values on a debit side, the total is going to be 181,000 on a debit side. And this is going to be the same amount on a credit side after summing the values, which equals to 181,000. And this is our trial balance. Part B of the question, determine the gross profit and the net profit from the information given below. Okay, so we have been given several information there. We have to remember that the gross profit is obtained from the trading account and the net profit is obtained from the profit and loss account. Okay, so for the given data above, let us prepare a simple trading account which is going to have like 3 columns. The first one for the details and the next one is for the debit side and the last column is for the credit side. Okay, so we start with the information given from the question. So we start with the opening stock, which was given as 8,000. And then we are going to add purchases, which have been given as 25,000, of which, summing this, we are going to get goods available for sale, which is total to be 33,000. Then next we are going to less closing stock, which have been given as 5,000. After calculating the values, we are going to get cost of goods sold, which equals to 28,000. On our credit column, we are having sales amount. The total is 38,000. Now we need to compare with the cost of goods sold, which equals to 28,000, in order to calculate the gross profit. The gross profit after calculating the values is going to be 10,000. Okay, now to find the net profit, we are going to list the expenses incurred during the period. So here we have electricity cost, which was 4,000. Then we have discount allowed, which was 2,000. The total expense equals to 6,000 from these values. Comparing to the gross profit of 10,000, our net profit is going to be 4,000. And these are going to be our answers. Question number 15, part A. Find the value of K such that the matrix, we've been given the matrix there, is singular. Okay, so this is the matrix problem. We have to recall that the singular matrix is the one with a determinant which equals to 0. Okay, so let us now find the determinant of this matrix and we are going to equate it to 0. So we say determinant equals to, in brackets, 2k plus 2 times, in brackets, k plus 3 minus, in brackets, 4k minus 3 times k. Okay, so now let us expand this expression. We are going to have determinant equals to negative 2k squared plus 11k plus 6. Okay, so now let us equate our equation to 0. We are going to have negative 2k squared plus 11k plus 6 equals to 0. Okay, so now factorizing this expression, we are going to have, in brackets, negative k plus 6 times, in brackets, 2k plus 1 equals to 0. Then either negative k plus 6 equals to 0, which gives k equals to 6, or 2k plus 1 equals to 0, which, solving the values for k here, we are getting k equals to negative 1 over 2. Okay, so therefore k equals to 6 or k equals to negative 1 over 2. Part B of the question, the vertices of ABC are A is 1, 2, B is 3, 1, and C is negative 2, 1. If triangle ABC is reflected on the x-axis, find the coordinates of the vertices of its image. Okay, so this is the transformation problem. Let us recall the transformation matrix for the reflection, which says R equals to matrix cos 2 theta, sin 2 theta, sin 2 theta, negative cos 2 theta. Okay, so we know that the reflection line makes angle 0 degree with x-axis. So let us substitute theta with 0. We are going to have R equals to cos 0, sin 0, sin 0, negative cos 0. Okay, so something also to remember is cos 0 equals to 1 and sin 0 equals to 0. Then our matrix is going to be R equals to matrix 1, 0, 0, negative 1. Okay, so now let us consider the transformation formula, which says image equals to transformation matrix times point. For this case, image will equal matrix 1, 0, 0, negative 1 times x, y. Okay, so starting with point A with 1, 2, the image is going to be matrix 1, 0, 0, negative 1 times 1, 2. Okay, so applying multiplication of a matrix, we are going to have image equals to matrix 1 times 1 plus 0 times 2, 0 times 1 plus negative 1 times 2, of which, solving this, we are going to have matrix 1, negative 2. Our next point is point B with 3, 1. So image is going to be matrix 1, 0, 0, negative 1 times matrix 3, 1. of which we are going to have image equals to matrix 1 times 3 plus 0 times 1, 0 times 1 plus negative 1 times 1, of which, solving this, we are going to have 3, negative 1. Our next point is point C with negative 2, 1. So image is going to be matrix 1, 0, 0, negative 1 times matrix negative 2, 1. Multiplying this, we are going to have image equals to matrix 1 times negative 2 plus 0 times 1, 0 times negative 2 plus negative 1 times 1, of which, solving this, we are going to have matrix negative 2, negative 1. So we have all the images for the 3 points as requested. Part C, solve the following simultaneous equations by matrix method. So we've been given 2 equations there. So first, let us rearrange these equations. We are having 2x plus 3y equals to 2, and then we are having 8x minus 9y equals to 1. Okay, so next, let us write these equations in a matrix format. We are going to have matrix 2, 8, 3, negative 9 times matrix x, y equals to matrix 2, 1. Let us call this as equation number 1. Okay, so now let A equals to matrix 2, 8, 3, negative 9. So let us now find the inverse of the matrix A. The formula says an inverse equals to 1 over determinant times adjoint of A. Okay, so to find the determinant, we are going to take the product of a main diagonal minus product of a leading diagonal. So determinant is going to be 2 times negative 9 minus 8 times 3, of which, solving this, we are having negative 42. And also, to find the adjoint of a matrix A, we are going to exchange elements from the main diagonal, and we are going to negate the leading diagonal, and then our adjoint A is going to be matrix negative 9, negative 8, negative 3, 2. Okay, so now let us substitute these values for the determinant and the adjoint of a matrix A in our formula in order to find the A inverse. Okay, so A inverse equals to 1 over negative 42 times matrix negative 9, negative 8, negative 3, and 2. Okay, so next, let us multiply an inverse of a matrix A, both sides of equation 1 above. We are going to have 1 over negative 42 times matrix negative 9, negative 8, negative 3, 2 times matrix 2, 8, 3, negative 9 times x, y equals to 1 over negative 42 times matrix negative 9, negative 8, negative 3, 2 times matrix 2, 1. Okay, so something to remember is a matrix times its inverse gives an identity matrix. So for this part on our left hand side, we are going to have an identity matrix. So our equation is going to be matrix 1, 0, 0, 1 times xy equals to 1 over negative 42 times matrix negative 9, negative 8, negative 3, 2 times matrix 2, 1. And also something to remember is a matrix times an identity matrix gives a matrix itself. So our left hand side is just going to have matrix X, Y. So applying those concepts, our equation is going to be matrix X, Y equals to 1 over negative 42 times matrix negative 9, negative 8, negative 3, 2 times matrix 2, 1. Okay, so now let us apply the multiplication of a matrix for our right hand side. We are going to have x, y equals to 1 over negative 48 times matrix negative 9 times 2 plus negative 3 times 1, negative 8 times 2 plus 2 times 1, of which solving this we are going to have x, y equals to 1 over negative 42 times matrix negative 21, negative 14. Okay, so now let us apply scalar multiplication of a matrix. We are going to have x, y equals to matrix 1 over 2, 1 over 3. Therefore, the value of x equals to 1 over 2 and the value of y equals to 1 over 3. Question number 16. A box contains 7 red balls and 14 black balls. 2 balls are drawn at random without replacement. Part A of the problem, we are supposed to draw a tree diagram. Okay, so this is the probability problem. When we are drawing the tree diagram, since we know that the ball is drawn and not replaced, then the second ball drawing will have a total ball of 20 instead of 21. So we will move like this, and then we are going to label each branch with its probability according to the information given. And the final result of our tree diagram is going to be like this. Part B, we are supposed to find the probability that both are black. Okay, so probability for both are black equals to probability of a black for the first drawing and then probability of a black for the second ball. And something to remember is and in probability, it means we have to multiply. Okay, so from the tree diagram above, probability of a black for the first drawing equals to 14 over 21. And probability of a black for the second ball equals to 13 over 20. Next, we are going to take the product of these two probabilities in order to find a probability for both balls are black. So we are going to have 14 over 21 times 13 over 20, of which after solving the values we are going to have 13 over 30, and this is the probability required. Part C of the question, find the probability that they are the same color. Okay, so probability of the same color equals to probability of black for the first and black for the second, or probability of red for the first and red for the second drawing. Okay, so we have to remember that or will means that we have to add the values, and AND will stand for the multiplication of the values. Okay, so from the tree diagram, probability for the first one to be black will equal 14 over 21, and probability for the second to be black equals to 13 over 20, and also probability for the first to be red equals to 7 over 21, and probability for the second to be red will equal 6 over 20. Okay, so now to find the probability for the same color, we are going to take 14 over 21 times 13 over 20 plus 7 over 21 times 6 over 20. Okay, so after solving the values, our final figure is going to be 8 over 35, and this is the probability needed. Moving on to part D of the question, find the probability that the first is black and the second is red. Okay, so taking the values from the tree diagram, the probability that the first is black and the second is red is going to be 14 over 21 times 7 over 20, of which after solving these values we are going to have 7 over 30, and this is the needed probability. Part E of the question, verify that the probability rule, probability of A plus probability of A complement equals to 1 by using the results in part B. Okay, so for this one, we are going to let probability of both a black equals to probability of A, which equals to 13 over 30, as calculated in part B above. Okay, so now probability of A complement will be the sum of all probabilities remaining from the diagram. So probability of A complement will equal 14 over 21 times 7 over 20 plus 7 over 21 times 14 over 20 plus 7 over 21 times 6 over 20, of which after solving these values we are going to have probability of A complement equals to 17 over 30. Okay, so taking probability of A plus probability of A complement, then we have the values we are going to have 13 over 30 plus 17 over 30. Solving this, our answer is going to be 1. Therefore, this has been verified as requested from our question.